Your first assignment is the last thing you have to work.
All right. Oh, I forgot my microphone. That would be handy. Apologies. Here we go. That's better. Now you can actually hear me without me yelling. Hello, everyone. Welcome to the last lecture before Flex Week. Thank you so much for coming. I know it's Friday afternoon and freedom in some way is so close. But yes, we are going to actually do strings today. Although I feel like now I should be like, we're doing strings. And then 2 hours later, oh, we've run out of time. No strings again. No, I won't do that to you. Strings, definitely. We're going to do strings. And then I'm just going to get to draw one diagram for linked lists, okay? Just one. I just want to show you what a linked list is towards the end of the lecture. And then we're going to do, I'm going to set a little bit of a pace today, but keep in mind I will recap as well once we go to week 7, because I'm sure that week 6 will be a good week for everyone and you might forget everything that we've done today. And that's all right, don't worry, I will recap. So that's really, let's get going. We're going to, I love linked lists. This is so bizarre. This is and so does Tammy actually. So apologies, we're going to get a bit overexcited for linked lists. I see that there is also, I see someone's asked me if I'm feeling better. I'm feeling a lot better, but I'm still, if you can hear, I'm still congested. So I guess these days you stay in your little germapalooza when you are congested. So I'm staying in my little germapalooza. With my dogs who don't mind my germs. So there we go. All right, and just quickly, I saw a few questions in the chat before we started. There are no formal classes next week in week 6, but we're running a few fun things as well. So I'll tell you at the end of the lecture what fun things we're running. So many fun things, and whoever thinks that they can, compete in a competition. Oh, well, there we go. This will be your chance. This will be your chance to shine. Anyway, and then we're going to have a few little optional lectures. They're not compulsory, they're not examinable, but just something fun if you wanted to. If you were like, oh yeah, I might as well listen to something, different a bit. We're going to talk about ethics and computing as well. And of course, we're also running help sessions throughout the whole of week 6. So there's going to be plenty of opportunities to come and ask questions, because we want to make sure that you are supported before the assignment is due. The forum we've picked up extra people on the forum so that you will be able to get answers quicker and more efficiently next week, so that you're able to continue with your assignments. So hopefully we've got the right balance of people and help sessions and everything happening, so that you can get a good chunk of your assignment done, because I'm sure that that week 6 will be much needed. At least you don't have to go to formal classes, and you can just stay at home and still do studying, I guess, but also go out and enjoy yourself, get a lot of sleep, lots of good snacks, a lot of that. Okay, so I love the polls. Are you keen for flexibility week? Some people are not keen. Oh my goodness, you need a break. You really do. It will be good to have a break in the content as well, because you need time to process everything that we're doing as well. Okay, let's get started for today. I feel like I should just keep stringing you along and not do strings. No, we're going to do strings. Strings are happening. Assignment 1. So I did crash the website for about 5 minutes today, because I was making some changes and I spilt some tea on myself at the same time. Then I pushed something that wasn't complete. So the website was broken for 5 minutes this morning whilst I tried to clean up my mess. But it got fixed straight away. You should be able to access the page. We'll look into that. Okay, so let's do it. Strings and linked lists. All right, on Tuesday we revisited pointers, and we kind of talked about what a pointer is in more detail. We wrote some stuff with pointers. Now, in the feedback, a few people asked me to recap pointers again. Unfortunately, I don't have time to recap them again, but I've tried to do an example with pointers still in there. So hopefully this means that we'll get more practice with strings, and also we'll get in your tutorials and stuff, you'll keep working through pointers, and your tutors will keep explaining pointers. And honestly, in week 7, once we start doing linked lists, you're going to, pointers are also going to make a lot more sense, because you'll see a really good use for them as well. Because I think often you've learnt this concept of pointers, but you have so far not really seen a very clear reason why you need pointers, which I think really kind of makes you think, well, what's the point? Why am I even learning this? So next week you will see a really clear reason for pointers. They're really useful in complex structures like a linked list. And today we're going to talk about why it will be useful to have a pointer there. So it will make a lot more sense. And I think that might be the turning point as well. We also talked about characters, some of their fun functions. Don't worry, we're going to go over some of that stuff again as part of our examples, and also you're going to have some exercises to help you get through them as well. So we are going to do that today. Strings. I saw a few people in the chat were already saying I'm going to string you along. No, strings. And then the one, the only, the truly magical, the magnificent linked list. I feel like that deserves like a little clap, a drum roll. I should have done a drum roll. No, I don't have that. So just pretend there's a drum roll for linked lists. So, okay, let's do it. Where is the code? Same place as it was on Tuesday. Tammy, if you can please post it in the chat. So in the chat, only Tammy today. She is running it as COMP1511, so please ask her questions. And I will answer some of the questions in the chat. If there's anything that is useful for me to talk about, Tammy will also ping me to actually answer it, verbally out loud. Okay, so that's our live lecture code. The next slide is strings. And also I should tell you that there is an achievement code somewhere in the lecture today. You might find it, you might not. We'll see. Okay, strings. What are strings? Thank you so much. Someone gave me a drum roll. Perfect. Okay, so what are strings? Strings are a collection of characters that are joined together in an array. It's an array of characters. Now, C is so weird because, weird. It's one of the special things about C is that an array of characters, so a string is an array of characters, but there's one very special thing about it, is that it has something that it finishes with, okay? And that's in particular for C. Okay, sorry, I'm holding a hot cup of tea, which is just waiting for me to spill it on myself yet again. So I'm gonna stop doing that. So basically, I'll draw it up for you as well so that you can see what I'm talking about. But a string is an array of characters that finishes in a special character called a null terminating character. So let's say you have an array, okay? And that array, okay, I'm drawing, it's not refreshing. Let me refresh my whiteboard, apologies. I set this up like 30 minutes ago, I was so excited. And now it's just not playing with me. Maybe it's my iPad that needs refreshing. Let's try this again. See, this is what happens. Not even my iPad wants to do string. Yeah, so there's no dedicated string data type in C like Python has, okay? What it is a string in C is an array of characters. So what you get is an array of char. So each element, let's say we've got the string and the string is hello, okay? Notice I'm using double quotation marks for a string, okay? So if the string is hello, what it's going to do is it's going to have each one of the array elements is going to be a char. And then each character is going to have its own index. So H in here, E in here, L, L, O. And then if you are a string, okay, so if you have these double apostrophes, quotation marks, then in C, you're going to say you're a string by having a very special thing to finish up with, and it's going to be the character, a null terminating character. So it's a slash and a 0, okay? And it's called a null terminating character in C. And that's what tells us that you are in fact a string. So it's always located at the end of the array, always, okay? So therefore an array has to always be able to accommodate this character. So, and we'll talk about how to create a string and how to declare and initialize it as well. And so this is what allows us to go through the string and to know when the string finishes as well, okay? So it's not displayed as part of the string, you're not going to see it, but as long as something is a string, it's going to have this null terminating character at the end of it. It's a placeholder to say, I am actually a string, okay? I'm not just an array of characters, I am a string. Because you can have an array of characters that's not a string, but if you are a string, you're going to have the null terminating character to finish it off. All right, so basically, and what we said, it kind of looks like this. So if you want to declare and initialize a string, okay, you can use two methods. The first one is obviously the more sort of convenient method because you're not doing something crazy then, okay? So it's an array of char. So I've said the data type is char. The name of my array is word over here. And I've got the square brackets to show that it's an array, okay? And then to initialize it equals, and see in the double apostrophes, it's what I'm saying, that's going to be a string. It's not going to be just some random array of char, it's going to be a string. So when I say hello over here, that's the string. And when I say assign this in, okay? When I say assign it in, what this array does is it makes space for 1, 2, 3, 4, 5, 6. It makes space for 6 characters because it will make a space for that null terminating character, okay? So it'll make space for each of the letters, and it will also make space for the null terminating character. Now this is the same if you remember when we initialized our arrays of int, we put them in between little single apostrophes. So remember, each one is a char. So it's exactly the same as saying I've got an H, I've got an E, I've got an L, I've got an L, I've got an O. And then you would have to say it has that null terminating character in there as well. Because if you're doing it like this, you're just really doing an array of char. So you need to be able to say, oh, it's a string. So I'm going to actually manually put that null terminating character in. Whereas if you declare and initialize it as an array of char just in the double apostrophes, that null terminating character will go in there whether you like it or not. Okay? So that is how we declare and initialize a string. And now some useful functions for your strings, because we're not going, oh, can you print it out using printf? You can indeed. And you're going to use, there is a few things that you can use, okay? So I'll talk about them when we print out. So you can print out using a printf, but we still recommend you do it as though you're pulsing through an array. Okay, so you course through an array. There is a %s in C though for a string that you could use, but sorry. Okay, and we'll printf a few things, so don't worry, we will do it. Okay. So some useful functions for reading strings. Okay, so if you remember on Tuesday, we did this getChar function, which got one character at a time from terminal. So whatever you wrote on your standard input or on your output, from standard input, you got one character at a time. That's what getChar was doing. Now, sometimes you have a whole string, okay, and you need something else. You can't just be getting one character at a time. You're going to go insane. So there is a useful function for reading strings, and that function is fgets. So not scanf, it's fgets. And yeah, some of you might try, you can actually do a scanf %s. Do not do it though, because there's a lot of dangerous aspects to doing that, which is why we don't do scanf %s. So fgets, okay, and the function goes like this. You'll call the function fgets, and inside it you'll put the name of the array that you want to store that word into, that string into, okay? And then you're going to have the length of that array. So what is the maximum length of the array? And then you're going to have something called a stream. In your case, you don't really have to worry. It's always going to be stdin, standard input. So in your case, it's always going to be from terminal, so you don't have to worry about it. The reason you have this stream is because, you could be reading from a file or you could be reading from something else. But in 1511, you'll only ever read from the terminal. So you don't have to worry about reading from anywhere else. Okay, so if you declare an array, for example, so let's say we've got a char array, and I've said that it's got a max length, so I'm assuming that this is a hash defined somewhere, whatever size it is. And then to read it in, to use that fgets function, I'll do fgets. The name of the array is array, so that's what goes inside here as the first thing, array. My length of that array is maximum length, so I'm going to do maximum length. And I've made a spelling mistake in there. That should be stdin. I'm sorry. That's me making a spelling mistake. That should be stdin. So standard input. Yeah. So standard in, and then we've got standard out as well, which is where you're putting something out onto the terminal. Okay. So it's not quite terminal. It's a standard input or a standard output. So it's standard out or standard in. You're getting stuff from terminal or putting it out to terminal. Okay, and now, and don't worry, we're about to do a piece of code as well. I know I'm pulsing a bit of information into you. I'm just trying to do a little bit, and then we're going to do an example of how it all comes together. So don't worry. And then Tammy will do also a poll in about 1 minute of how we're going, where we're at, if the pace is okay, or if I need to slow down. Okay, so how should I keep reading things until some point that I want to stop, kind of thing? Okay, so we can do that by using the null keyword when you have to do fgets. Okay, so what that means is that fgets will stop reading when either you've got too much length here, so something you're not going to be able to read something in, so you've got too many characters for the length that you've specified, so it's not going to be able to read anything in, or where if you've got that end of file reached, okay, whichever one comes first. And the end of file for this string is to do the null. So we have learned about the EOF, but in this case we're going to have a null for fgets. So get char is EOF and fgets is a null. Don't worry, really, you know, you look this up all the time as well. You know, I often will forget which one is which, and I'll just quickly look up which one ends which one, you know, which one goes where. Okay, Jack, also you said you don't fully understand get char. Don't worry, we will cover it again. I will cover it again. Everyone wanted to do strings. So we're going to do strings, and then I'm going to do like a get char example if there is time today, but if not, I'm going to revisit all of that as well. Okay, excellent question, Darren. Does the max length include the null terminating character? That's up to, it does. So the size of it has to be whatever the size I need plus 1 for that null terminating character. Okay, and it's easy to run out of space. Well, not really, not if the max length, in this case it's 15, so it's easy to run out of space, but if we have 100, maybe, depending what you're putting in, not as easy to run out of space. Okay, so then we would check if it's equal to null, which means that a control D is pressed, and that's when we would stop reading. Okay, and then it has an FPuts, so like get char, and then it has a put char. Fgets has an FPuts. So they're kind of the same, except one does characters and the other one does strings. Okay, so they're really very similar in how they operate as well. So FPuts, you just tell it what to put out. So you tell it what's the name of the array that you want it to actually put, and then you tell it where that is coming from and where to put it out to. And again, for you, it will always be a standard output. Now, I barely ever use FPuts. I don't like FPuts. I don't feel anything for it. I'll just print F if I have to print. But you can use this FPuts to print out a whole array straight up. For a string. So for example, if you had an array, again, a character, a string, and it's an array of characters of max length, then you can read it in with fgets by saying the name of the array, the maximum length, and where it's coming from. Clearly a copy and paste spelling error there. And then you can output the array onto terminal by saying fputs, the name of the array, and where you're outputting it to. Okay, should we try to do a little bit? Of coding? How does everyone feel? Let me see the poll. I reckon it's probably going a bit too fast. Yeah, so a bit of a mixed bag of tricks. Good pace 66. Too slow. Oh goodness, I can't speak any faster. You'll see me coughing. Okay, we'll try and see a coding example and whether or not it's going to make it a lot better. Okay, let's switch over to our code. I'm like, what am I doing? Yeah, I'm clicking code and okay. All right, so I've written a whole bunch of things here. So if you look at the code without the lecture notes, you know what's going on in the piece of code as well. Okay, so there is a a library for strings as well. That library is helpfully for us called a string.h library. So whenever you are going to be using any functions that are strings, then that you are doing anything with strings, because we do have a bunch of functions that are available to us with strings, you will include this string.h library as well. Okay, so I'm going to look at a few functions here. I'm going to look at string copy. What that does is it copies a string from one array to another. So it's got a destination and a source, and we move from one string to another. I'm going to do a string length. So that's the length of the string. Now note, when you find out the length of the string that doesn't include the null terminating character. It doesn't include the null terminating character. And string compare. So this function compares two strings and returns 0 if they're the same. They're probably the most useful ones, but if you're interested in finding out what other ones there are, I have provided a link in the lecture notes as well so that you can go and look up. So if you ever need to do something with a string, look up if that function exists, because it's much faster, much easier to do that than to write something yourself. Okay, so include stdio, and the first thing we'll do is just use an FGets and an FPuts. Okay, and I'm going to include my string library as well for when we want to do stuff with strings and use any of those functions. So string.h. Okay, now I've got a max length here of 100. Okay, so my array size is going to be 100, which means I can have something that's 99 letters because I'm going to need to have one space for the null terminating character. So let's have a look. So we've got our int main void. Let's declare an array where we will place the string. So we'll have a char array max length. So what I've done here is I've created an array. Let me draw it up for you. Actually, let's go through the code, then I'll draw it for you. Print out, type in a string to echo. I'm going to get that string. So what I'll do is I'll use an fgets function. So this is a special function that I can use to play with strings, so I don't have to do anything special. It's already done for me. I'm going to specify first off the name of the array. So it's this array name to take stuff into. I'm going to specify the length of the array, so the max length. And I'm going to tell it where to take it in from. So your standard in, so your standard input from the terminal. Okay, and then I'm going to print out the echo of the type where it is. So look at this, I'm using a %s here, and I'm going to print out whatever it is. I'm just going to get rid of this for a second so that you can see how to use the other stuff. Okay, so first of all, we're going to play with fgets. So I'll just comment that out for now. Okay, so we've just used this fgets, and you know what else? And let's see what it does if we draw it up. Okay, so let's say I'm going to tell it that, what word should we read in? Has anyone got a word that we should read in? And you know what? I might just make this, I'm going to make this 10 so that I can draw it. Otherwise, I'm not going to draw 100 boxes. Oh, goodness, look at us. We're just, puns, of course. Okay, so when we start out, okay, when we go through our code, the first thing we do here on line 23 is we say, create an array for me. It's called array and it's of max length. So what I do then is create an array of max length, and it's going to have 10 things in here. So it's going to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the indexing underneath it is going to look like this. It goes from 0 to 9. Okay, and each one of these is going to be a char because I've created an array of char. So each one of my elements is exactly the same. It's all chars. Okay, so I've got a few good suggestions. I'm going to read in, I'll just start with the first one to start with. Yeah, so that's right, Fatty. So the actual size is 9 because the null value has to take up a space. And then we might read in something that's greater than 9 to get a feel for it. So let's say I want to say fgets the word bonjour, okay? And then I call this fgets function, and I'll say pop it into this. So this is called an array. So pop it into this array. That's where it's going. The length of this array, the size is max length, which is 10, and I want to read it from standard input. Okay, so it's going into array, so it's going into here. It's got the size of 10. That's what the array is, so I can't really do more than that. And read it from the terminal. So the word bonjour. Okay, it's going to go B-O-N-J-O-U-R, and then it's going to do a null terminating character over there. Okay, so that's how it's going to read it in. So if we run the code now, so let's run the code. Okay, and run it. And let's do our... So it's going to give me that string is what I wanted. So now what happens if we do a word that's longer than 9 letters? Who can give me a word longer than 9 letters? Who's going to give me something longer than 9 letters? Oh, someone's asked a good question. Oh, well, there you go. Tammy's answered it. Both make F get stop. Yeah, so if you press enter, that's when it starts to do it. Or if you've maxed out, it will stop doing it. Oh, gosh. Oh, supercalifragilisticexpialidocious. Yes, amazing. Oh, I'm worried that I won't be able to spell that. Oh, mathematics. Oh, that's a good one. Oh, competition. How can we look past that? Okay. Let's say we want the word competition. Okay, what's going to happen? Again, you want to read it in. Your size is 10. So what are we going to do? Let's do COMPUNTITION, and you're going to run out of space. So it's not going to be able to do it. Yeah, it's going to give us an error. Let's see what it does. Okay. Let's run it again, and this time we're going to do a competition. I'm struggling spelling it. So look at what it's done. Very unfortunate, but so it's put in as many characters as it can, okay? So it's read up to, and if you have a look over here, it's read up to enough, but then the last character had to be a null terminating character. So then it kind of, it stopped taking in once the size of the array was exhausted. Okay, so it's like I don't have any space. I've taken in what I can. I've put a null terminating character there, so now we're done. So it still took in 9 letters. Okay, no runtime error because no issues really occurred. It can still read it in. It just doesn't care that it's had to cut it. Okay, excellent. So anytime you'll have something bigger, it's just going to cut it itself. Okay, so now what happens if we try and do an FPuts? Okay, so what happens if we try and do an FPuts instead of this printf instead? So FPuts is like the sister or brother function to fgets. So what it's going to do is it's going to really take the output out to a terminal. Again, if you do standard output, and you just specify the name of what you want to output there, and then you also specify where that output is going to. So it's going to stand it out. Oh, fail. There we go. Let's save it. Let's compile it again. And let's run it. So if we do, I didn't type it very well, but there we go. I've made a spelling mistake. So yeah, so there we go. And if I run it again and I do something longer, then you can see it's outputting also just going to the 9 characters, then it's got a null, and then it stops. So it's kind of, it's not the formatted version of print. So again, the printf, if you remember from Tuesday, it's the formatted version, which means it needs a type. It needs a lot more, it needs a lot more information. But this just puts out whatever was in that array. So, and any question? No, Tammy, I can see there's a few questions going, which is nice. Someone's doing some nice things. Can you input numbers? Yeah, they're just characters, the ones in the ASCII table. Excellent. Why was there no line break? Okay, excellent question. The reason for that is because I'm using an FPuts. And if there's no line break, there's nothing to do a line break. I'd have to printf a line break, which is why I hate using anything but printf, just because it's got so much more, capability. So now it would actually do an enter. The reason there was a line break in this one was because it read in the enter as well as a character. So it kind of did it as well because there was enough space, but here it filled it up with everything that was a character. So it filled out the 9 letters and then it stopped. Here we go, that's 9 letters, and then it just only had space for a null terminating character. So I hope, does that answer it, Nathan, Mark? Did I just answer why it doesn't do that? Yeah, so once you go to a limit, it's all over. It will not do a new line for it because it didn't read in the new line. The new line occurred over here after the S. And if I haven't taken in after the S, then I'm obviously not going to put out what happened after the S. So that's why there's no new line. Whereas here, the new line occurred after the R. So then that's still okay. Okay, excellent. All right, so now we've got FGets and FPuts. Let's try out a few other functions that we have. How to create an array with infinite input. Oh, well, this is one of the things about arrays is you can't really have an infinite input. Anyway, in C, the way you declare arrays, you have to give them a size. So sometimes it's not the best data structure to use. Perhaps something else is a better structure to use. Because if we create an array, we have to give it a size straight up because of the way it's stored in memory. And so, what happens is that we just guess what size we want. Usually it's a huge number, and usually we waste a lot of space. It's just, you can't really do infinite amounts, infinite arrays. And the reason for that is because computer memory is not infinite either. So you're going to run out of things, okay? You're going to run out of things to say, you're going to run out of things. You're just going to run out of space. Okay, so now if we do a little bit of a few functions just to see that there's different functions available to you as well. Okay, so let's try and read in a string into an array until Control D is pressed, and that's indicated by the null keyword. So all we're doing is we keep writing into this array and then just outputting what was written, and we'll keep doing it until we do Control D. So we're going to call the fgets command. Okay, it's going to go into the array, which is over here, our array. The array maximum length is going to be maximum length, and then we can do a standard input. So that really never changes for you in 1511. It's always going to be stdin. Now, until that's null, we want to keep doing whatever's happening in here. So what I'll do is I'm going to comment out these sections, okay? Because the first time I'm going to read it in will be over here, okay? So I'll take it into the array, and then I'll print out the string is blah, okay? And then I'm going to print out the string, okay? Okay, and let's manipulate our string. So let's find the length of the string first, okay? Oh, I can see, yeah. So the way that so in the lecture notes, the reason it says array with square bracket is because that's how the function is defined. All that means by that is that you're sending it an array. So that's not using it in the context of actually having an array, if that makes sense. No, you can't write an end of file. It's different for this one. Yeah, so you're going to need to write null. Okay, so to find the length of the array, let's do, I don't know, the function is called strlen. Now, mind you, I just want you to understand, none of us go around memorizing all the functions that are available to us. Usually, if I have to do something with a string, I'll look up the string standard library, and I'm going to look through it and see what functions are available to me. And so if you do that, let me do it for you to show you. String.h standard library. Okay, so I'll go to something like this, which will also give me the whole, like all the things that are available to me in this library. So I'm going to see all the library functions that I can use, and I might need some of them or not. So I'm about to use something called string length, which is over here. So strlen, okay? I'm worried I don't want, so just this computes the length of the string up to, but not including the terminating null character. So it doesn't add in the null terminating character when it's calculating, when it's calculating the size. It's really just giving you the size of whatever your string is. Because it would be a little bit confusing to have the null terminating character in there as well. Okay, so string length, and I've got to give it a string that is, I'm going to calculate the length for, and it's going to be, the string is going to be, what's it called? Array. Okay, oh God, I can't spell. It's not happening. Okay, great. Okay, so we have a string length, although let me do it simpler just so that you can see how it's going to work. Okay, I'm going to store it into an int because otherwise it's just going to, I'm going to call this function. This function returns to us the number, so I don't want to throw away that number. So if I want to do a string length, let's just say I'm going to do a string length of bonjour. So I've got it in here as my string length, and let's see what it does. So it's going to give us a string length. Let me get rid of this. Let's save it. Okay, let's run it again just to see a few of these functions being used. Great, forgot a semicolon. Save it again. Let me clear this so that it doesn't look so messy. Compile. Let me input out, okay? Okay, let's try it out. Thank you. Oh, Struggle Town, here we go. And let's try our first one. The string is bonjour, the length is 7. 1, 2, 3, 4, 5, 6, 7, so that's correct. If we do the next one, it's going to give us, well, it's not going to give us much because it's going to cut it off because our array is only 10. So it's not going to like us very much. But then the length is 7 because I'm just testing a string in here. So that's going to be the same. And then if I press Control D, that's when it's going to stop and exit out. So that's when I do that while loop until it's going to have a null. So someone said, is it possible to return a string initiated in a function? So you can't return an array, okay? You can't return an array. And because a string is an array of char, you can't really return a string, if that makes sense. But we have learned that you could do something perhaps with a pointer, because the first address, the first address of an array is like a constant pointer to that array. So we will kind of look at a way that we could do that in a little bit, but it's not really, no, you can't return an array. Okay, I keep wanting to go into more in-depth explanations, but I'm going to cut myself off because otherwise it becomes more confusing. For now, just you cannot return an array, and we'll just go with that. Yeah, so if you're going to do string length, you're going to need to do the string in, whenever you have a string, it should be in double quotation marks. And yes, you can pass an array into a function, but it's really, you're passing in a pointer really. So we'll do an example like that today actually. All right, let's try another one. Let's try compare. Where did someone say? I'll just look in the chat in a second. Let's try and copy a string. Okay. So one thing about it is you cannot, so you can't copy, because you copy character by character, right? You can't just copy an array to an array, if that makes sense. Like you can't just say, I want to copy one to the other. If you were to write that function, it would be doing it character by character. So lucky for us, that function already exists, and it's a string copy function, okay? So it's this function called strcpy, and this function does that for you, so you don't need to do it yourself. So string copy is the function that copies one function from one array to another. Okay, so here it is. So copies the string pointer to. So if you go into it, the code for it is kind of already written. This is just an example of how it's used, but if you are interested, there is code for it as well. So this is very useful, okay, because otherwise you're there writing a function that copies a character by character from one array to another. So you use string copy, and what you can do is you can copy from one to another. What should we copy? Let's copy into our array, and it goes destination and source. I think I always have to look this up. Destination, source. Yes. So the first one is destination, and the second one is source. So the first thing you specify is a destination. So I want it to copy into my array, okay, and then I say the source. So what I want to copy it into. So I want to copy, I don't know, into that array, okay? So what it will do then is that your array is now going to be something else. So if I print out, then you, oh, forgot double quotes. Is going to be okay, so let's try running that. I always like that second between it compiling and it going to not compile. You always get that like feeling. You're like, is it going to compile or is it not? Okay, let's try one that will go in. Okay, and so here was the point that we copied a different string in. So then we popped it in and made it into boo. Okay, so then we do, I don't know, what's another string? Then it's done that. Okay. So then it did it again, okay? So then it just copies from one to another. Yeah, so, okay, I hope I'm not gonna I hope I'm not gonna throw anyone off. So string copy, you can see, oh, I didn't mean to press on it. What it does is there's two pointers being sent, okay? And the reason for that is because if you send the array, you're really sending a pointer in, because the name of the array is the pointer to its first element, okay? So that's why, yeah, it really is the string copy function. It used an array name because it's a pointer. So that's why it's you just say what array name you want. This could be another array name as well, or usually, you know, it's a constant string. So you give it a string that you want to copy into. Okay, and let's do a comparison. Why not? Okay, so let's do a comparison here. Okay, the comparison function returns an int. Okay, so I'm going to do an int compare string 1, and I'll just show you how to use it. The function is called strcmp for string compare. Again, you don't have to remember all of these. If you need to do something with functions, you'll go and look up some of the few function, you know, things that you kind of need all the time. You will remember the ones that you use all the time. And let's say I'm going to compare, I don't know, bonjour and hello. So I'm going to specify these two things. Obviously, they're not the same. So it's going to return something to me that's not 0. So when they're the same, that's when it returns 0. Okay. So let me print out. keep forgetting double quotation marks today. Don't know what's going on. Okay, so let's compare it when the two things are not the same. Press Control D here to finish it, clear it, compile it again, run it again. It didn't take as long this time, don't feel as bad. Misspelled that. Okay, there's two strings are not the same, so it's given me -1. And from memory, it gives, it stops like at the first character that doesn't, non-matching character. And I think, I can't even remember how it does it, but I think it does, depending which word is different to the other one. So if I swap them around, it's going to return a different value. So if I do this way and the second word as this one, then it will return to me a different value here. So if you want to try it and play around with it, you can. So it's returned -1 because they're still not the same. So if we make them the same, it will return 0. I should have done where it's, hang on, it's because they both didn't match at the first character. I know why it's not doing what I want it to do. Okay, so if I run it again, have I saved it? Are the two words the same? I swear they're the same. That should be returning 1. Okay. I didn't compile it. Thank you. That's why it's not. Yeah, good. Excellent. You see, it's Friday afternoon. We're so close to the finish line. Thank you. Thank you. I'm like, I swear I saved it. It doesn't have a star. Thanks for pointing that out. Forgot to compile it. Okay, so now it's returned 0 because they're the same. Okay. Okay, so that's a string compare function, and then kind of just all the different functions that you have for strings, which is pretty exciting. So I think that now is a good time to take a little break, and then we can come back to do some other exciting stuff. So hang on a second, I've stuffed up something. As per usual. Any questions so far? And Tammy, sorry, I'm so used to saying Tommy. Tammy, could you please run a poll so that we can see how everyone is feeling and where everyone is up to before we go on our break? And then pop your questions in the chat so I can answer them as well. Now I've lost where I am. Here we go. Here's the chat. Okay. Yeah, we're going to be doing some memory. We're going to talk about memory first to prepare us for the linked list. Why doesn't string compare return a 0 for false and 1 for true? Because whoever wrote it decided that 0 when it's all the same. And because it's not a 0 or 1, there's 3 possibilities for a string compare, and it's based on the comparison, okay? So it's based on where the characters don't meet. It compares them one by one, and then if the first word is bigger, it returns something, and then if the second word is bigger, then it returns something else. That's why. So it's not just a 0, a 1, or a -1. There's 3 things that it can do. And unfortunately, we can't really change these standard functions. Okay, that's a great question, Fatally Orange. Why do I sometimes see things using char or array? You're seeing an array, but then also string copy seems to take char star, and it's because an array, the first, so I think, let me just draw it up over here. I don't even know what screen I'm on now. I think I'm on the right screen. I'll show you why, and hopefully very briefly. Let's have a look. Okay, the reason for that is if I have an array, okay, and let's say the array has, I don't know, 3, 5, 6, 7, 8. So it's an array of ints, okay? Okay, oh God, you can't even see it. Definitely that's unhelpful. Okay, so let's say I have this array. Now, if you remember, okay, I have memory addresses. So if each one of them is an int, okay, then that means that each one of these also has a memory address. So let's say this is at 0, 0. An array is stored in memory consecutively, what means this is why you can access things so easily just by specifying the index, okay? Because in memory, it's stored as one large chunk wherever it is. And that's why also we need to say how big we want, what the size of the array is, because it creates this chunk straight away somewhere in memory. You can't have this disjointed array. It's all in one in memory, and then it's based on whatever size that you need. So it's all going to be, I don't know, this is 0, 4. This one will be 0, 0, 8, 0, 0, C, 0, X, F. I can't remember what comes next. If I calculate it out, 1, O, I can't remember. Anyway, they're consecutive, so they're one after another, okay? So let's say we have these memory, oh God, struggling. How did I do that? I don't know where I am now. There we go. That was one way to fix it. Okay. So when you have an array, each one of these has a memory address, right? And let's say this array is called array. Now, if you sent the function, the array, which you've noticed when you send something to a function, you send it just with the name array. You don't need to say, when you send an argument to a function, you don't need to give it the square brackets. You don't need to give it that. All you're saying is, here's an array for you. Could you please do something with it? So all I'm saying is, here's an array for you. Please do something with it. Okay. Now what I'm actually sending it is an array. Inside, when you send an array, is going to be this address. So what you're doing is you're actually sending a pointer, okay? It's actually a pointer to the very first address of the array. And this is why we often also send a size of the array, because if you have the address where the array starts and the size of it, then you can access anything in that array and you know exactly how much space that array is taking, and it's all very flexible for you, ready to do whatever it is that you need it to do. Okay? All right. How's that? I hope that helped a little bit to understand why you send it an array and suddenly it's taking in a pointer, because that name is an actual pointer. All right, let's take a little break, and then when we come back, we will continue. Please pop your questions in the chat and vote on the poll as well. Okay, here we go. Little fun for you. All right, coming back. I love that everyone had so many good ideas, dates, cars, stealing things, amazing. But yeah, Zachary got the right answer. Ah, there you go. He had the same riddle in high school for public. Yeah, so this riddle is the start of like cryptography, public and private keys, which is, most of the riddles that I give you are actually the start of some sort of algorithm in computing, or otherwise. So yeah. Okay, so well done. Let's I'm just about to sort of, we're about to go, okay, we're about to go all in. We're about to go all in into memory. So this is the moment that, I have nothing else to say. This is the moment that things get real. If they weren't real for now. Okay, so let's have a look at some memory. All right, let's talk a little bit about memory. Okay, so I keep saying, okay, we've got a lot of memory. We don't care what you do with it in 1511. You waste it, doesn't matter. We don't care about efficiency. But, it's something to keep in the back of your mind as you go forward as well. You will start caring more about memory. We don't yet care about it, but we do need to know how we give out memory because that impacts on how we do things as well. So there's two types, of memory. There's memory that's given at compile time, and we don't really have we don't have control over it once the program is running. We don't have any control over it. So once it's given out at compile time, it cannot be changed. And that's the memory when we declare our arrays, when we declare our ints, our chars, whatever else. This kind of stuff is given out at compile time. So for example, for this arrays, each int is 4 bytes. It'll give 40 bytes to this, and that will be that. I have no control over this memory. Once it's given, I can't get rid of it. So I can, overpower the whole thing. So think about something like this. Okay, so far we've kind of said, okay, let's say I've got an array. That array only lives between my curly brackets. And then as soon as my program ends or my curly brackets end, that array will die. Okay, so we don't, our variables do not persist across the different areas. So if we have this kind of function here, for example, so we've created data inside the function, okay? So we've created this data inside here, and then we've tried to return a pointer to the array. So we've given it this array out to whoever our main function, we've returned it. This is actually not going to work that well because when you close this curly bracket, this array actually dies. So what you're giving it is you're giving it a null pointer. You're giving it a pointer pointing to absolutely nothing, okay? It's a pointer to memory that no longer exists. So this is memory that's allocated by the compiler at compile time. And so sometimes we want to have memory that we would like to control, okay? Because we are all about world domination, and that means we need to control the memory. So we have this, I think I'm just a bit too lyrical here. Wonderful opportunity. I guess it's a wonderful opportunity, but there is an opportunity to allocate memory by calling a function called malloc, okay? And this function is going to become your best friend over the coming weeks. You will be mallocing left, right, and center. And what malloc stands for is memory allocation. It's called dynamic memory because you're in control of it. So when you malloc up some memory, okay, you have to say, you have to tell malloc how many bytes you want, okay? It's not just randomly, taking random bits of memory and throwing them at you. Here you go, have some memory. You got to tell it how many bytes you want. And what it will give you back is it will give you back the pointer to the piece of memory that it created on the number of bytes, okay, that was specified to the input of that function. So, and don't worry, we will play around with how you actually use it. A lot of coding stuff, you really need to get your hands dirty. You need to get in there, and you need to really practice it to be able to understand what it's doing. And you also need to be able to get it wrong, okay? Because that kind of also tells you what is the right thing that can happen. Okay, so when we use malloc, what it does is it actually allows us to create memory as we need it. Okay, so I was saying, you know, we've got this array, we've got to create it at compile time. We're like, all right, let's give it 1000 ints. So it's gonna, and then I end up using 3 of them. So it's not very efficient. Whereas with malloc, I can create memory when I need it, and then I can kill it when I don't need it anymore. So it gives me the ability to play around with memory. It also gives me the ability to create things that will last and that will keep hold of until I need to use them. But what if I do run wild and just keep asking for more memory and more memory and more memory and more memory? What if I get very, 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 very greedy? Well, what happens is once I malloc some memory, it's mine to control. But if I don't start killing all this memory that I'm asking for, it will crash your computer because you're going to, eat up all the memory that the computer has. And that's what's called a memory leak. And you're going to look at a few fun memory leaks in your tutorials as well. So a memory leak occurs when you malloc some memory. So when malloc stands for memory allocation. So when you take some memory, you dynamically allocate some memory, you ask for some memory, it gives you a pointer to that memory, but you do not free that memory afterwards. So as a result of that, your memory is sort of, it's lost and it can never be free, causing a memory leak, okay? So there's some dangerous things. It's actually, in my next message, I'll share an article with you. It's one of the security concerns around C is that you have this malloc memory that's never freed. And so you have these ways that you can get into systems as well because you can access random bits of memory that might have changed to something else. So you can free the memory and you should be freeing your memory. Every time you allocate memory, at the end of using that memory and needing that memory, you should free that memory. So you need to give it back. You have to be polite, okay? Don't be greedy. If you don't need it anymore, free it up. And to free it, you just use the term, the function free, okay? All right, now, how do you know? So I said when you want to use malloc, you really want to tell it how many bytes you want, okay? Because otherwise you're not just going to be able to, keep giving me more, keep giving me more. You need to know how many bytes you're going to create. And I'll draw it up as well after we write this piece of code. So we use something called sizeof, okay? And sizeof is a function that allows us, it's a function, okay? You don't have to write anything about it, but you will also become very good friends with the function sizeof because what sizeof does is it tells us the size of different things. And that means you really just have to say, you use the sizeof to know what's going on because, it's not like I'll be like, okay, malloc 60 bytes. Because I haven't computed if that's enough for me. How do I know? But if I know that I'm going to need to use 20 ints, then I can use sizeof, and I'm telling it I need the sizeof 20 ints, so I'll be able to use it. Okay, so let's do it. So this is just an example of sizeof. So for example, I'm going to use this array here just as an example array, okay? It doesn't mean anything. I'm not on, that's not helpful because I'm not, thanks for joining. I'm trying to finish the lecture. No, wrong scene. Here we go. I'm on the code now. All right, so what I'm trying to do is I've got this array here, okay? The array has 10 items in it, and I've initialized it all to 0. And the reason it's really just for demonstration purposes. So this is an example of using sizeof. For example, I want the size of an int, okay? This is wrong. Okay, so sizeof returns a long unsigned, which is an LU. You don't really need to know that. You'll never print out what sizeof is. It's by definition, okay? So it's not something you can change. It's a long unsigned, so that's why you print it out with an LU. So I'm using this as an example. You will most probably never have to print out what sizeof returns unless you're doing some debugging. Okay, so the size of an int is something bytes, and the way I use the sizeof is I say sizeof, and then I say what I want the size of, so an int, okay? Then if I want the size of an array of ints, okay, then I will use sizeof, and then in here I'll say that I want my size of the array. Now, if I want the size of 10 ints, all I do is 10 times size of one single int. A double is size of a double. A char is the size of a char. So what it allows you to do is it really just allows you to be able to understand what size off is without just picking out random numbers that you might need. So it allows you to be more precise with how much memory you actually need to get. So let's compile it. Off.c. Apologies, I got overexcited over here. Here we go, that's much better. Okay, and let's run size off. And so it's printing out for me that the size of an int is 4 bytes, and it does that by size off an int. Size of an array is 40 bytes because it's an array. There's 10 ints. Each int is 4 bytes, so it's going to be 40. And if I do 10 ints, okay, that's why I multiply by 10. So if I want to have 10 ints, then I'm going to do 10 times size off a single int. So it's going to give me 40 bytes. So that's why I have the times 10. And then a double is 8 bytes, which is why it's called a double, because it's double the size of an int. And then a char is 1 byte, one teeny tiny byte. So this is really just an example of using this size off, but we're really going to be combining it with malloc to be able to allocate it some space, or to be able to get some space that we want. And I'll show you what it's doing. I'll draw it up once we do the malloc. Okay, let's do let's do a harder piece of code. Okay, so the LU stands for long unsigned, and the reason I had to use an LU is because size off returns an LU, so I don't really have a choice. I have to return an LU. You will probably never need to do a long unsigned in 1511, so you don't have to worry about it. But as an example, that LU is there because it's a long unsigned. And I have done a note for you up the top. So I'm using it LU here because size off returns an unsigned long int. So if you go to this piece of code afterwards, you'll be able to see what on earth it means as well. Okay, let's have a look at a harder piece of code. I'm loving all the puns happening now about bytes. Bytes are just too easy, aren't they? Love it. Okay, so let's have a look at, I don't know, I've said a simple example. I'm not sure it's that simple, but let's try and do a few things in there so that we can get a bit of practice with a few things, but also using malloc. Okay, let me just have a sip of my tea. All right, let's do it. Yeah, I feel like hashtag free the bytes, absolutely. You got to free. If you malloc, you've got to free. Okay, it's really important. We have to free. Okay, so again, I'm going to go on and on about this array. In the previous time, we've kind of used, bite of cake, I love it. We've used an array. We've given it random sizes, 1000, 1200. You'll see big sizes of arrays. And usually I'm just guessing what size I need to give it. Usually it's a waste of space. What if I knew the size of the array and then I could give it some memory based on the size of that array? Okay, so now the functions malloc and free live inside the standard library.h. So, oh, Jeremy, I really hope so too. Please let me know if this example is too much once we start doing it, okay? Okay. So I'm going to hash include the library standard lib.h. So usually as you go on now, these are the two libraries that you will be including almost every time with your examples as we go on, because you'll be using malloc a lot from week 7 onwards. So standard library.h, and then your just normal standard input output. Okay, so I've said I want two functions here. And so this is for Fatally Orange. We had this is what they were talking about. So hopefully this will clear it up a little bit more. I've said that one of those will be reading an array function. Yeah, little bytes. Don't forget to chew. All right, so we've got a pun. No, oh my God. We don't have a pun. I just need to move on. Jack, C type is for characters. String is for strings. Standard libraries for malloc and free. And maths is for maths. So I want to reverse an array basically, okay? So I'm going to allocate a memory for an array, read in that array and print it all out in reverse order. Okay, so what do we have? What do we have? So I'm going to say that I want a function that reads the array, and I'm going to give that function a pointer, numbers, okay? And I'm going to give it a size as well. And then I'm going to reverse the array. And again, I'm going to give it a pointer, numbers, and then I'm going to give it a size as well. All right, I really love that last one. Another one bites the dust. I feel like the music is playing in my mind as well. Okay, then we have an int main void. Okay, obviously, I think you all know the int main void now. Let's find out the size of the array. So it's still not quite like that I can allocate it so this means that I haven't created an array yet, okay? And once I've compiled this, I am now running, okay? So normally I would not be able to do this with an array because I'd have to declare an array and I'd have to give it some space at compile time. So this is the way to do it if I don't want to do it at compile time, if I want to do it at runtime. Okay, I've got a size. I'm going to print out how many numbers would you like to scan. I'm going to scan in how many numbers. Excellent. Now I want to allocate some memory space for that array and return a pointer to the first element. Okay? That's a good one, Esha. We will wreak malloc on the world, and you could steal so much memory if you do that. Okay, so we're going to use malloc here. So inside malloc, we give it what size we want. Now, I know that all of these, I'm scanning in numbers, so it's all going to be ints. So I'm going to use a size of an int. Okay, so this is going to give me some bytes. And here I've also asked, how many numbers would you like to scan? And I take that into my variable size. So this is a size of one int. And if I want the size of size ints, then I would do size times the size of int. So what I'm creating here is I'm taking some memory and I'm creating enough memory to house size numbers of this size of int. That's right, yeah. Now, that's great, but malloc returns something to me and I really need what it has returned to me, because when I create this chunk of memory, so when I've called malloc, let's say what I have is something that looks like this. Sorry, my whiteboard's refreshing. Okay. All right, so when I call malloc, let's say this is also not an accurate representation, but just trying to represent, let's say this is my computer memory, okay? Great. When I call this malloc, and then I say size times size of int. Okay, this part here, size of int, that's 4 bytes. Let's say just for example, okay, for example, this is random, okay? I've done 10, I've said it's 10. So this is going to make me 40 bytes of memory. So it's going to go somewhere in my memory and it's going to take a chunk. And let's say this chunk is 40 bytes. Okay, that's great. I've done such a great job. I've got this memory, but where on earth is it? How do I use it? I need something that will tell me where this memory is, because there's chunks everywhere that might have something in them, but where is this piece of memory that I just created? So what malloc returns to you is it returns an address of the memory that it has created, okay? So it returns a pointer to the first element, what you've created. So I need to know where on earth to start this memory. So what's being returned to me is a pointer, okay? So because otherwise I wouldn't know where on earth to approach this memory to use it up, okay? So what I want to do is I want to be able to get this address. Now it's returning to me a pointer, okay? Which means that, and I know that it's an int, okay? Because I'm scanning in numbers, I'm getting the size of ints. So I want to store ints in this memory that I create. So if I want to store ints, my pointer is pointing to ints, if that makes sense. So it's all kind of type driven, but it all aligns to each other. So I'm returning a pointer, okay? So a pointer, I'm gonna have a star, and I don't know, what would you like to call it? I'm gonna just call it numbers, okay? It doesn't matter what you call it, that's your variable name. So I've created a variable name that is a pointer. So it's a pointer that points to int, and it's called numbers. So what this will do is it will give me the address of this piece of memory that I've created here, okay? So now this bit of memory, the starting bit, is called numbers. So it's basically given me the first chunk of memory, the address of it, which is a pointer. Okay, how does a pointer have a type? It's what it points to. So what is the address of what is it's storing, kind of thing? That if you dereference it, is it going to be an int, a char, a double, and so on and so forth? Okay, so great. Now I have an address of this memory. That's fantastic. Use it to my heart's content. Although, if I want to use this lovely memory, okay, I need to know that there is actually enough space first. So whenever you use malloc, because you don't know, you're just like, I want memory, I'm gonna ask for memory. But does the computer have enough memory to give out to you? Okay, so you need to check if the computer has enough memory for you. And we do often check whether or not we have enough memory to give out, because if we don't have enough memory to give out, you're going to return a null there because you haven't actually given anything. Okay, so you're going to get a null pointer. And that's what we're going to check here. So if we want, that's my fault, apologies. I was on the wrong screen and I pressed the down arrow. Okay, so if we want to check whether or not it's created enough memory, what we're going to do is we're going to check whether or not it's null. Okay, so if this pointer called numbers is equal to null, that means that no memory was allocated, okay? No memory was allocated. Yes, you do, sorry. I always forget semicolons. Thank you very much. You do need a semicolon. Okay, so if it's null, that means no memory was given because there wasn't enough memory to give. So that means you've already been too greedy. You've taken too much memory. Okay, and then I'm going to give an error. Why not? Malloc failed. There's not enough memory to allocate. Excellent. Okay, and then I really want to exit out of here, so I'm going to return 1, okay, because that's going to exit me out of the program. Because if I don't have enough memory, so if that pointer is null, that means I can't really do much. So Jack, that's so what it means, not enough memory is equal to null. The reason for that is, if you remember, when a pointer has nothing in it, it's null pointer. So what it's saying is, if it didn't have enough memory to allocate, it's not going to give that pointer an address. So that pointer is going to get a null. It's going to get a nothing. And that's why we check whether or not the pointer is equal to null, because if it is, it's got nothing there. There's nothing going on. Okay, fantastic, great. We've done that's fantastic. Then we might perform some functions, and we might even write those functions. Why not? Should we write those functions? Yeah, let's write those functions. Why not? Okay, and then in the end, after we finished using this memory, we really want to free it up. Okay, so let's free up the allocated memory. We're going to do it with the keyword, the function free. And my pointer was inside here, inside this numbers. So that's what I'm freeing. I'm freeing this memory that starts with numbers. Okay, so that starts at that address that I requested. Okay, so let's have a look. Let's write a few helper functions here. Okay, so we've done that now. I'll get rid of the to do, and we've done this now. No, we haven't. We're about to do it. Okay. All right, so let's write a function that will read numbers from standard input, and it will print them out. Let's do that. Okay, what's our function going to be? Well, it's easy because I've kind of given a prototype here, so I'm going to copy this down. Actually, I'm going to take both of them down. Okay, here we go. Excellent. All right, so the first function is here. Now, what the first function is getting when I do read array is I'm giving it numbers. So what I've given it here is a pointer, isn't it? But it's an array because I'm storing enough space for however many numbers, right? And I'm also giving it the size, so how many things there are. So it's going to get the pointer to the first element, so that very first section of my memory, so this little bit here. And if there's enough for 40, that's 10 elements. So I'm giving it the size is 10, and the memory address of the first one. So that means I'm giving it a pointer, and I'm also giving it a size. Okay, so now what I want to be doing is I want to be reading stuff in. So let's do an index is equal to 0, and then we'll do our usual while loop. Now there has been someone that has been very keen to learn for loops in this lecture. I'm sorry, I'm not going to teach for loops this term, but next term we have talked about it as well. It might come next term. You feel free to use for loops if you want, but we do most things with while loops here because it's easier to teach just one way to peruse through. Okay, so whilst I is less than size, what we're going to do is we're going to give a little prompt to the user, please enter a number. And then what we're going to do is we're going to take in that number. So I'm going to scan a number in, %D. And now if you remember what happens, where will I scan it into? My pointer to the first element is numbers, and I'm going to do it at index I. Even though really it doesn't feel like I have an array anywhere, but I actually do because I've requested enough for 10 or for example 10 things, and I was given the memory address of the very first one. Okay, so I'm going to scan them through, and then I'm going to update my index, increment it, and there we go. We've read in this array. Excellent. So now we can do maybe an array that's going to reverse print the array. It should really be reverse print, but anyway. Okay, so what's a good way to reverse print something? I think you had this as a lab exercise as well. So you should be pros at this now. What are we thinking? It is very likely that you will run out of memory unless you're trying very hard to run out of memory. Yep. Okay, we're going to go downwards. I love it. So in this case it is, Jeffrey, in this case it is in the form of an array because I've given it, I've told it I want size times something. So I've created 10 lots of ints. Next to each other, right? So what I've created is an array because I created 10 lots of ints next to each other, and then I gave it back the first part of it. Okay, so reverse array, I'm going to go from the back. So I'm going to print out, just so that it looks nice, print out a numbers reversed R. Okay, oh gosh, yep, here we go, good. Actually, maybe I'll do a new line as well. New line? Yeah, let's do a new line. Why not? Okay, I'm going to start from the last one just because it's easier. So I'm going to go size -1, and that's the last element of the array. And then I'm going to subtract out. So I'm going to say whilst last is greater than or equal to 0, please go backwards out of here. So print out the number. So print the number at numbers, and my index is last. You could have called it I or J again, whatever you want. I just thought, why not call it last, but you can call it something different. And then I'm going to go down, so decrement it. Okay, great. That should do it, maybe. Let's hope. Let's try to compile it and run it, see what it does. Okay, that moment, I got that moment. My heart was in my chest. How many numbers? Should we do 10? I shouldn't have done 10 because that's too many. Okay, anyway, we're doing 10. Okay, and I didn't print them out very nicely either. I can see over there. I should have done a new line after each one, shouldn't have I? There we go. That's, otherwise you can't tell what's going on. Okay, let's try it again. Compile it, clear, run it. Let's do 3 numbers. Okay, 13, 14, 15. No, 15. And then it's going to reverse them out to 15, 14, 13, and so on. Okay. No, you should not be using malloc for every variable in any function. Because, so when you use malloc, you're creating memory and you're holding on to that memory. You're controlling the memory. For most variables, you don't actually need to do that, okay? So only if you need to allocate memory at runtime, it's the only time that you would use malloc, okay? Our variables are given memory at compile time, which means you can't change them. And you can't change that piece of memory they have. And usually you don't need to, right? So it makes a lot of sense for them to just be at compile time and let them be and let them live. But if I want to dynamically allocate memory, so if I want to take memory as I want pieces of memory, that's when I will want to use something like malloc, because it will allow me to do that. I'm moving quite slowly, but it's coming. It's okay. And this is coming for a linked list, because a linked list is a structure where you create memory as you need it. No, you would not be using malloc or memory allocation in assignment 1. You will have to use it in assignment 2 in the context of a linked list. So, I feel like maybe I should introduce a linked list now. Just like as a brief to show you why you need runtime to no runtime. Maybe I will, just a little one, and then we can go back to structs and pointers, because we haven't done a pointer to a struct, which we're going to need. How does that sound? Yeah, let's do that. Let's do that. I'm with it. Okay, I'm going to introduce you to a linked list, and I'm going to draw it up for you, okay, just as a visual thing, okay? We're not going to do any functions with it. We're not going to like talk about it in any sort of intense way. I'm just going to introduce you to what it looks like, okay? And then we're going to talk about what we might need for it. Okay, so lecture slides, amazing. Okay, so new structure, linked list, you've been waiting so long. Actually, strings is the one that you were waiting so long for. But once you see linked list, you'll be like, actually, linked list was the thing I really needed, I really wanted. I just couldn't have lived without linked lists in my life. And so now you know, this is it. You get a linked list now. Okay, so like an array, a linked list is used to store a collection of the same data type, okay? So what's the point of it? And the whole point of it is, again, because an array is allocated at compile time, it's not particularly efficient, right? And you have to guess where we're at. So linked lists are dynamically allocated, which means that every time I need a piece of memory, I'm going to malloc that memory and I'm going to call it and get myself something. So a linked list is made up of nodes, okay? And they can be stored anywhere in memory, okay? So it's super neat. And the only way to get through it is you can't do it like an array. You know, I need the 7th index, so I'm just going to call the 7th index. No, for a linked list, you always have to start at the first node and go through them all, okay? And I will explain why in a second, because I want to draw it up for you because you can see what it looks like. Tammy, it's happening. We can draw finally. Tammy loves, if you're in Tammy's tute, she loves drawing as well linked lists. This is the jam. Oh, it's like a big scavenger hunt every single time. So good. Okay, so let me erase this, okay, and then you'll see why we need malloc. Okay, so let's say that I have this piece of memory over here, and I've got chunks here that are taken, chunks here that are taken, chunks, 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 chunks. Okay, and I'm going to do a linked list. Okay, so suddenly I decide I need this dynamic memory. I'm gonna need a first node, okay? So my nodes, each node has some sort of value in it, and then it also has the address of the next thing. Someone's done it. Oh, I forgot to switch screens. My goodness. Yes. Who's amazing? I'm on the wrong screen. Yes, Tammy's also telling me I'm on the wrong. I got so excited about drawing the diagram, I forgot to switch screens. I'm sorry. Okay, sorry. The level of this linked list diagrams are just too overexcited. Here we go. I'm sorry. Okay, sorry about that. Just been waiting for so long to draw a linked list. And now it doesn't make sense what I've drawn. Okay, I'm gonna have to redo it. God. Okay, let's try this again. Okay, so each node of a linked list, let's say this is a node, okay, and a linked list is made up of many nodes, okay, however many I need. I can just take them as I need them, okay. It's got a few things in it. I've got some sort of data, so whatever I want to say, okay, but then also it has the address of the next thing I need, okay? Because I can't access things all at once, I need to tell where is the next thing, and where is the next thing, and where is the next thing. So this is what I mean. It's like a bit of a scavenger hunt, okay? We have to go to the first thing, and then go to the next thing, and then go to the next thing, and then go to the next thing. And we don't know how many are there unless we go through them all and count them. We really need to know where we're at. So basically what happens is with a linked list, and why it's so useful, is let's say we have this big chunk of memory, which is like your computer's memory, and you know that you need some dynamically allocated memory. So you know that you've got some data, you don't know how much data you have, okay, but you will dedicate space to it each time. So it starts and you're like, okay, I need a piece of data. And let's say this memory already has a lot of things in here, and whatever, right? Wherever, it's all random. And so you call Malik and you say, Malik, can I please have a node? Could you give me a node, please? Okay, I want a node. Oh my God, Jeffrey, yes, it does not have a next address. Well done. It points to nothing, and which is going to be an amazing way we're going to learn how to do things with it. Okay, you Malik some memory. Your computer's like, okay, where can I squeeze this memory in? I'm going to squeeze it in over here, and I'm going to create a node for you over here. Excellent. And what I'll do for you is I'm going to take the address of this node. I'm going to take the address of it and give it back to you. I've created that node. Excellent. And then you go on and you're like, okay, I need another node because I need to store some more information. So it's like an array, right? I'm reading in a list of 5 things, for example, but I don't know how many that is. And I'm going to read them into a linked list instead of an array. So I've read in the first thing, I've placed it into this node. Now I want the second thing, okay? So I'm going to malloc some memory for another node to store my next bit of information. Let's say it's the number 2, for example. Okay, so I'm going to malloc some memory for another node, and my computer's going to go, I think I'm going to put it over here this time. And it's going to put the number 2 over here. Okay, this is my number 1. But now I need the memory address of this. So you give the memory address of this, you store this for the node. And I have to say that this node is going to go to this node. And then I might have a third node somewhere squeezed in here. And then I'll go to the third node. I might have a 4th node over here squeezed in. So I'll point to it. And the only way to point to them, because they are spread out wherever, okay, in the link, they're spread out wherever in the memory, is to have the memory address of the next thing. So what a linked list looks like, okay, and let me get rid of this mess now and show you what it would look like. This is a neat drawing. That's not how it looks like in memory. Is you will have a node here with the memory address of this next thing here. This one will have, so let's say we're reading it, a list that has 1, 2, 3, 4, okay? The number 1 would be here, and I'm just going to do fake memory addresses. And you allocate them as you go. So let's do that actually. Let's allocate them as we go. Okay, so I've got, first thing I read in is 1. I make some memory and I put it in here. And right now it's pointing at nothing, okay? So it's empty, okay? Okay, great. So now I want to make a node for number 2. So I'm going to create a node somewhere else. I'm going to place 2 into it. And I'm going to make 1 point to 2. So this is going to have the address of this. So if the address of this is 0xFF, then I'm going to store that address in here so that I can point to it. I'm going to point to the next thing. And then now let's say I want a node for 3. So I'm going to pop the 3 in here. And that means my 2 is going to point to wherever this is. Okay, so it's going to point to this one. So I'm going to go this way. Okay, excellent. And now I want a node, so I'm going to malloc some space for a 4. So then I'm going to place the 4 in here, and let's say the 4 is over here. So it's going to point me to here. So I'm going to say that's going to point me to the next. And when I don't need any more, it's going to point me to nothing. And we know that nothing in pointer land is actually a null. So it's going to point to absolutely nothing. Okay, Tammy, could you do a poll? How's everyone feeling about just this like theoretical linked list scavenger hunt? I always think about it like a scavenger hunt. I have to get to a location to get the address of the next location, to get the address of the next location, to get the address of the next location. Okay, people are confused. That's okay. Don't worry. We will do it again and again. This is just a first introduction. Pre-teaching. Yeah, so linked list will malloc every single node that it needs. As long as it keeps needing space, it will malloc it. And only when you get rid of nodes is when you kill them. You will see it in code in week 7 because we need to do a few more things to do it into code. But what it allows you to do is it allows you to really make use of chunks of memory wherever they are, okay? As opposed to an array has to be like this. It has to be, you need a 1000 array. It all has to be consecutive. It all has to be in one place at the same time. Whereas a linked list, things can be anywhere in your memory. And all you do is you just have an address of that thing and you point the previous one to it. So you're scavenger hunting. You have to be at the first to get the address of the second. You have to be at the second to get the address of the third. And anytime you need something in this linked list, you always start from the start and you go all the way to the end until you go to wherever you go. And you do have to kill things. If you are deleting a number, you'd have to kill a node. So if you do not, if you have a thing where you don't know the size of something, you don't know how much memory you will need, that's when it's really useful to use a linked list because you don't need to know how much memory to allocate for it. You can allocate the memory. You can allocate the memory at runtime. So when you need something, that's when you make some memory for it. Yeah. So Jeremy's done another like analogy for it. Following Google Maps, yeah, go to this street, turn here, go there. Yeah, so yeah, linked list is not indexed. It's not like an array, okay? Because there's no way to get through to an index. If I say I want the third linked list, it's not going to know where that is. I have to go from the first one to the second one to the third one to find it and count that I'm at the first, at the second, at the third. There's no indexing. Yep, what's the question? Now, I fully understand that a linked list, the first time you see it, it's like mind blown, very confusing, can be quite confusing. First time you've seen anything like it, don't worry. I'm using this as a pre-teaching moment. So I'm using it as a way to like very basically introduce you to the concept so that we can do it in much more detail when we come back from break, okay? And the reason I don't want to do it in a lot of detail now is because I fully expect you to forget everything we've done today over the next week. And in what situation would you use a linked list? In a situation where you do not know, where you don't know how many things you need. So they are dynamically sized. It means you can shrink them, you can grow them as much as needed. So you don't have to waste memory. So that's why a linked list is useful. All right, I can see quite a few people are confused. Don't worry, it's okay, it's okay, it's okay. We will be doing this in a lot more detail. I promise it will make a lot more sense. Anything special happen if the last node links back to the first? That is such a great question. You do not do it in 1511 is my answer. There are weird things that you can do. You can have circular lists, you can have double lists. We're only doing singular linked lists, okay? You can do some pretty cool things, not in 1511. We're just going to do a single linked list. So Jeffrey, that's right. So if you want to access a node, you have to go one by one, which absolutely has its own inefficiency, okay? Because you are wasting time. What if you need 100th thing in the linked list, okay? And Daniel, that's right. You will be using a loop a lot, okay? So just like an array you'll be looping through a linked list though. So you are right. It can be inefficient, for which you will learn other data structures as well. But it's more efficient than an array in this particular context. If you want to have something that you don't know how big it is, then that's when you would use a linked list. So always in computer science, we have different data structures for different types of problems, and not everything is efficient in each one. Sometimes you'll be able to solve things in 10 different ways, but perhaps one will be more efficient than another. We don't really care about efficiency in 1511. So what do you do in that case? Then you shouldn't have used a linked list in that case. So it depends what you're looking for. Sometimes losing efficiency is okay if the context of the problem makes sense. And, how much efficiency are you using? If it's 10 seconds more, or is it, 5 hours more? Yeah, so it's like, well, it's not quite pointers pointing to pointers, because you're not pointing to a pointer, you're pointing to a node. And we're going to talk about what a node is in week 7. Yeah, there's always a trade-off in computing. Great question. Nodes are not a pointer type. They're their own type. And if you saw the way I've drawn it, what type do you think it is if it's storing a little piece of data and also a pointer? What do you reckon this type is? And I've drawn this kind of type before. What do you reckon this will be over here? Not an array? No. Yes, a struct, because it's holding two different things. It is indeed a struct. Each of your nodes will be a struct. And it will point. Well done. Excellent. And again, don't worry, we're going to go over it in a lot more detail as well. So well done. It is indeed, every node is a struct. All right. I know this is don't worry everyone. This is very confusing. First up, you will become absolute experts at this. I promise. Okay. Yeah, I'm just trying to just slowly explode your brains in the lead up to week 6, flexibility week. Everything is linking together. Thank you, Tammy. All right. And on that note, what I'm going to do is I'm going to finish up because I feel like I have hurt you enough for a Friday afternoon. I hope that you all have a good rest and catch up. Flex week, there are no formal classes. We do have a social competition. I'm going to talk about it in a second. 2 bonus ethics talks for those interested in how ethics is dealt with in computing. We have a lot of it. Help sessions are still running. Please check the timetable, and forum will be monitored very closely. All right, if you're interested in our competition, it is going to be on Wednesday at 1 o'clock. You can register via the QR code. I'll also send around some details on Monday. And we've got 2 ethics lecture talks by Dr. Sebastian Sokoa Grayson. He is wonderful and very fascinating. He specializes in philosophy, but he's very good at speaking. So if you are interested in how we deal with ethics, we're going to make those videos as well available to you. So come along for a chat as well about ethics. On Tuesday at 4 p.m. we're doing normative ethics for computer programmers, and on Friday at 3 meta ethics, and we can talk about that if you like. They are optional. You don't have to come. It's up to you, really. Any feedback, please leave it here. I hope you actually have a break over Flex Week. Please remember, I know you've got an assignment to do, but please remember also to sleep well, eat well, and rest up so that you're ready for week 7 for all of our scavenger hunts that we will be doing over the next few weeks across the linked lists. So have a wonderful break, and I'll see you all in week 7. Or actually on Wednesday for those of you that are punning. See you. Bye.